Hi everyone, this is the Beer Watcher. It is April 25th, 2017, and I am on the Jet Propulsion Laboratory, or JPL, to see what they're up to today. Well, a little more than that. Well, we have here is a new ultra-thin optical devices shape light in exotic waves. Yeah, they made this 2 years ago. Not just a patent, it's working. What are they doing with this technology? Well, let's dig into this. Researchers have developed innovative flat optical lenses as a part of a collaboration between NASA, JPL Laboratory, and Caltech, both in Pasadena, California. These optical components are capable of manipulating light in ways that are difficult or impossible to achieve with conventional lenses. Wow, this is insane when you see what this is. New lenses are not made of glass. Instead, silicon nanopillars are precisely arranged into a honeycomb pattern to create a metasurface that control the path and properties of passing light waves. Yeah, like an active lens, right? Applications of the devices include advanced microscopes, displays, sensors, cameras. Did you catch that? Displays, like Project Bluebeam, a projector. Yeah, sensors, cameras. This is an amazing set of technologies. The implications are huge of what they can do with the manipulation of light with these flat lenses. Will help more compact, robust imaging assemblies, mass produced. Currently, optical sensors are made of one component at a time. Not anymore. But this new technology, very similar to the one used to print semiconductor chips onto silicon wafers. Yeah, silk screens. So you would conceivably manufacture millions of systems of microscopes at a time, or cameras. Seen under a scanning electron microscope, the metastructures that the researchers created resemble a cut forest where the stumps remain. Let's just stop there for a second. Stumps. Here are your silicone stumps. Okay, this is a conceptual drawing of these silicone stumps that are thousandths of the thickness of a human hair. Now, that rotate and change the diameter of each pillar. Sit by carefully varying the diameters of each pillar and rotating them around their axis. Let's stop there for a second. Here's my theory, because they're not going to tell you how this really works. They're just kind of being vague. But let me blow the lid off this one. I believe what they have done here is put a layer like this cutaway view of a LCD screen, just like a TV set, right? But instead of putting LCDs, liquid crystal layers, they've got these silicone pillars in their place. And when they apply the voltage to this voltage sensitive silicone pillars on these XY axis, in other words, a microchip can apply voltage to X and Y axis on a particular pixel and turn the color off or on. But instead of LCDs, they've got silicone pillars that can change shape and size, affecting the electromagnetic property of light. Because if you can bend its electromagnetic property, you can change and bend light. That's how they're doing it. And that's very key to the video that I'm going to show you next. But let's just read a little bit more. Polarization refers to some light waves. Now, I'm trying to stay focused here. Now, what they can do is they can Now look at this, millimeters thick, 1/100th of a thickness of a human hair. Okay, additionally, the flat lenses can be used to modify the shape of light beams at will, instantly, like a TV screen. That is crazy. Semiconductor lasers typically emit elliptical beams that are really hard to work with, and the new metasurface optical components replace expensive optical systems to circularize the beams. Now, back to here, phase. Changing the phase of the wave has to do with the separation between peaks of the light waves. The light waves in phase, if they're in phase, it's called constructive, and they're destructive light. The constructive light will produce a more powerful wave, like a laser. Constructive light. Manipulating its phase into the degree which light ray bends, which in turn influences whether the image is in or out of focus. Okay, let's stop there for a second. Why is that important to take lenses in or out of focus? Because you can hide objects that way, like a planet, like this simple video from a conventional lens, not like what's used in outer space, which I'll prove in a minute, right there. So here I take a lens in an easy demonstration, pulling an object out of focus with a conventional lens, bending its light away from your eyes. You don't see it, moving the point of convergence away, because it is seen at the point of convergence. If you change it, it is not visible. It's not really that complicated. Now here are the lenses, the lens array in outer space that we see. Now I'm building up to a very awesome point with this, so please hang in there. This time-lapse video over Australia shows so much. First, we see the oscillating Fresnel lens, which we'll get into the NASA sun pattern. We see the fake sun traveling. I'm focusing on the lens array for right now. We'll get into the fake sun in a minute. Now, see this lens here. They're not moving with the sun. They're near the horizon because Planet X is coming at us at the ecliptic plane, which means we're going to be watching this thing. If we're ever going to hope to see this Planet X coming in at the Earth's ecliptic plane, we need to see it on the horizon. And that's where they need to hide these lenses, right here on the horizon. And have you noticed that all the Planet X videos are always seen on the horizon, not just where the cameras are? You see that? Okay, so we have lenses here, and here, and here, big and small, massive array, and I believe these are the ultra-thin lenses, which this matrix is failing. And hang in there, because I will show you absolute proof that this is failing in a grander scale, and perhaps in a few short months, we will be seeing it as this completely fails, because these active lenses will fail. Why? I'll explain just a little bit later. Just hang in there. So let me go back to the NASA sun patent here. This is the NASA sun patent. I will leave a link to the patent. From the sun simulator, this is the sun. This is the sun emitter. This is round. This little concave disc is the black dot. Here it is looking at it sideways, reflecting the light before it bounces on the convex mirror and bounces out to the Earth. And next here is a FAA camera of the projection as it passes through the lens. It is being projected. This thing is magnified. We see evidence of the sun simulator projection. Why is it hexagonal? Because that's the shape of the light source. Then, without any further, I believe that the James Webb telescope, which was due to be launched in 2018, is actually being used. as part of the sun simulator. This object here is part of the sun simulator. Let me look at the beryllium, gold-plated beryllium plates. These as a separate component here. The main component is in this video, the James Webb Telescope. Here they are making this thing, and many have asked, how big is it? Well, now I can answer your question. It is the size of a tennis court. Here this guy is working on it. I believe this is the actual object. Now, NASA is saying they haven't even launched this object. I believe it's already in space. This here would be about the position of the Fornell lens. Here are some more pictures of the conceptual drawing, not the actual drawing of this thing. You can go to the website. I'll try and leave links in the description of how this thing unfolds into space. This bolt beam here folds all the way back. These part fold to the side. This is the sun shield. I don't believe it's quite. Well, this sun shield serves, it's basically a beryllium, very thin shield that there's 5 layers of it, and the basically keeps this side cold. Now they say that the gold reflects the infrared light. They want to keep this side cold and protecting this side from the sun facing side so that this doesn't get hot. That's what they're saying. Is that true? Partly true. Now here is an actual photo of the, they call this an infrared space telescope. I believe this is part of the Fornell. This would where the mirror would be, and the spinning Fornell lens would be at this edge here where the light bounces back, and they would have put another mirror on the other edge of this thing. Nice photograph, by the way. So that picture you just saw would have been this portion of it right here. Now this sun disk is still missing from this picture, and so is the spinning Fornell lens, but I will continue to put this puzzle together. So next, let's move on to the further evidence of the Fornell lens. Now this is from the Xylon channel. This is amazing. We got them. This thing, watch this thing spin as he zooms in on this black dot. Not a camera apparition. And I got proof that it is nothing to do with the camera, because this thing disappears completely. That is the spinning dot. He's looking right down the barrel through the hole. You got to be at that hole. And I bet this thing actually kind of rotates a little bit. So that's why it changes, disappears, and reappears a little bit while he is viewing it. Not everybody can see it at the same time. You got to be looking down this thing as it rises. Notice nobody sees this black dot while it's straight above the sky. It's only while it's low on the horizon. So please, I'll leave you a link. Wow. And I want to pause here for a second. Now, please notice that you do see the yellow real sun here and the white fake sun in the middle. And there is a lens in front of this entire system here. And you can almost make out the edges. So the yellow true sun and the white fake sun, all in one picture. And this thing rotates. Want some more evidence? Here's an infrared spectrum of it. Here's the infrared, watching it on an FLR camera. Anybody can go buy one. Just exactly the same thing, rotating away. It's cooler. And I suspect that this thing probably has a 1-year life expectancy from all the heat that's being focused on this Fornell lens because it's right at the focal point of all that light, like a magnifying glass. This thing's been overheating. Has this been falling from the sky on a regular basis, and NASA's been hiding it? Maybe. Now next, for the point of the whole video, I would also like to show you my explanation from the Identify This channel and what she's seeing in the sky. This is pretty amazing as the matrix is falling apart. And she has the lens system failing. Now, this is no ordinary lens system. Like, again, this is just a big TV screen in the sky, like I described earlier. Let's see if I got some pre-recorded time-lapse videos of this, but you could see this is happening on cameras all around this area. And I believe it's the Nemesis star that's in close approach, nearing close to the Earth, near the orbit of Mercury. Yeah, that close. As it gets close to this thing, the brightness and the magnetic effects of all the planets in the system are overloading this lens system, which is magnetically warping and actively changing this light system and blowing out the electronics. I knew this day was going to come, and so did they. What do you think they're going to do when this thing gets too big? Look how the light is now coming through, is failing to warp and change because of the magnetic field, and it actually creating heat in the atmosphere and bending the light and warping the light in front of the lens, creating distortion before our very eyes. Yeah, I think that's exactly what this is. Here's a quick video of the James Webb Telescope, conceptual, just how easy this. It has not been launched yet. Well, that's what they say. I think it's already out there. Is it really a telescope? Yeah. No, I think it actually is the one and the same. The Sun Simulator. This rocket's never been launched like this. No telescope. That's the promise. That's what we paid billions and trillions of dollars for, so they can hide this incoming system from our eyes. So it launches in outer space. Very similar to, and here it puts it into a heliosynchronous orbit. The solar cells are deployed, and they don't even finish. Here we go. And this thing continues to unfold. I do believe that part of it's true. And the sun shield is released, which keeps the 5 layers of sun shield protected from overheating. This could stay icy cold. And there's that boom that comes down and deploys the James Webb Telescope. Just go look it up on YouTube. I don't think it's actually a telescope. Look, we even have the mirror effect here. These will extend out and complete 1/3 of the portion of the Sun Simulator. Now, many will still ask, why are they doing a fake sun? Again, I will have the same answer: to hide the unexpected solar eclipses of our sun, like we see in this Fox News time-lapse video. Now, here we are, classic example, the chemtrail clouds. Hot chemtrail clouds don't have ice because that came out of a hot jet. It was burned, right? Look, here's the gas. Most people are not dumb enough to fall for that. But look at this eclipse. Now, notice how this outer diameter does not change in size. And I like this point right here. If you notice that you only have light here, look at this eclipse as it actually closed off the light, just like an eclipse, a normal eclipse. And then once the threat of the eclipse is gone, they no longer chemtrail. Look at that, people. I've got one more video that shows. Let me show you just how that works. Now, some of you have seen this before, but I have to show it again, explaining how this fake sun works. The light represents the sun, which the Earth orbits around. The flashlight orbits around the Earth in a heliosynchronous orbit. And then when clouds pass at high altitudes, you have a small sun, and low altitudes, you have a big sun. Small sun, big sun. See how that works? Small, big. Now I've got time-lapse videos that proves this. Now, that would be absolutely impossible if that was the real sun. But this is what I call the flashlight effect, small and big. Let's look at how that applies to a solar eclipse and why we're seeing the things we do in the sky. Here is a solar eclipse. It's being eclipsed. I've got a lid. Then we put a fake sun in front of it. Now, since the object blocking the sun is smaller than the sun, we're going to get the sun dogs. But as it approaches the sun, it blocks out the Earth, and now we're getting the dark halos like we are now. Please go back and watch some other videos about this topic. I'm running out of time. And again, here we are with the fake sun simulator in outer space, reflecting from the space station. Notice the sun is over here. And look at this sun disk object here turning off and on. Now, last I checked, we'd see the sunset. Okay, does that even look like a sunset to you? Doesn't it start from the horizon? Right. I have other videos about this too. This just proves the fact. Oh, this looks awfully familiar with the sun dogs that we see from around this same effect that we see with the light coming at the 9, 6, and 3 o'clock position. On all my other videos, I believe the sundog days are over because the planets are so much closer that they've basically pinched off the light, and now we're only getting this. Again, the meteorologists want to call this ice crystals. But if they were ice crystals, where is the full spectrum rainbow? Where's the purples and the greens? Ice crystals? Well, you at least got to say they're chemtrails. Watch this. The black dot thing, remember we talked about this? Oh, that's a camera aberration. Well, no, it's not. Then how come it's reflecting on the water? Come on, it's reflecting on everything if you get the right camera angle. Most people don't take the time to bother, but this thing actually rotates. Yeah, it rotates. Now, I know I'm kind of laboring this point. So here, over in Australia, is the spinning Fornell lens. If I can get... So here is the rotating lens projected because we have a lens system in front of it. Let's play the video real quick. Go back and watch it in my video archives. Here's the spinning Fornell lens rotating once again in front of it, but this lens system is now failing. Let's see if we can try and watch one nice... I know it's a little redundant, but I'm trying to make this most comprehensive fake sun video I have ever made. Right there. Yeah. Some of you have said, Jeff, you're You're crazy. Your fake sun idea is insane. Then you tell me, why has the Germans actually turned on a fake sun in this huge fake sun simulator? Yep, they turned it on. Here's a picture of it. Here the Germans are standing in front of it. And last but not least, is this the Fornell lens that fell from space? This is from the Steve Olson channel. This is from an analog camera taking pictures of the sun itself. Look at these concentric circles of the spinning Fornell lens. Look how this thing rotates. I believe this thing actually fell from space. I think it actually has a 2-year lifespan. These strange balls, I think, look at this thing. I think that's it. I want you to notice this thing, how it has 2 orbiting hinges here. We have the hinge here, which allows it to rotate. And then we've got this hinge here. So it rotates like a gyroscope. I don't believe this thing rotates in 100, 360 degrees. I think it has a rotation that allows it to move around to aim its light wherever it sees. And these 4 light sensors that it has here. Let's look at, check this out. This is how it originally found, with this dog in the background. And all these cables and wires are attached to it. Does this thing have a lifespan? Does this thing fall? And was this thing attached to it? I think it's possible. It certainly seems to look very similar to the Fornell lens with this pattern here. Was it a gas tank? I don't know. Still thinking about that one. It looks like an asbestos chamber. Could have been coated with a gold coating on it, and it melted on re-entry. So, don't know for sure. That's my theory, that they keep falling from space and they're intermittently every few years. So here is a shiny version of it that fell from space. This guy from the Sunday Express News. This is old news, been happening. So let's look again at this failing lens array, that we could see this thing just being overloaded by the magnetic fields of the Nemesis star and its planets and all its intense magnetic fields, just totally overloading it. I believe these people actually go up getting intense sunburns too. I wish I'd like to get a straight time-lapse video of this, right in this position where these lenses would be on the horizon, by the way. And the channel explain this. I will leave a link in the description of this failing lens array. And it is pretty stunning. And you could almost see the light shining between these lenses here. And these active lenses must be computer controlled, probably from the space station, whether they're getting shorted out, the inability to control the manipulation of light. And I also believe this could be part of Project Bluebeam. And I have one final thought to share with you, which is on Miss Willie channel, this amazing super dark halo, which was over in Colombia, hope I pronounced that right, that since we have these panels in place that can project images, do you suppose that this may someday be the fake alien invasion of a giant mothership? It wouldn't be that hard, since we've already got the chemtrails as a display, the background, and the projectors known as the ultra-thin lenses from JPL and Caltech, easily able to project images on that part of Project Bluebeam. So I also want to show you one other thing. The cooling system of this star, this guy here on that control panel. This is the cooling system from this device here. Shows like the back side of it. Probably a different device, but it is a cooling system. Anyways, just a theory. Please copy, like, and share this video. Thank you for watching.